An isosceles trapezoid has a perimeter of 42 inches. Each of the congruent non-parallel sides is 5 inches long, and the trapezoid is 3 inches tall. How long are the two parallel sides? We'll start by drawing a picture here. First of all, we have an isosceles trapezoid. So we need to know what that is. Now, a trapezoid is a four-sided figure where we have one pair of parallel lines. An isosceles trapezoid is where the other two sides have the same length. So we'll go ahead and draw this. We've got a trapezoid. So we've got two sides that are parallel. Okay, and it's isosceles, meaning these other two sides have the same length. Okay. Now, we've got lots of things going on here. We've got a perimeter of 42 inches. So I don't know all these lengths, but I do know a couple of things. First of all, each of the congruent non-parallel sides, so that's these ones here, are 5 inches long. So this is a 5, and this is a 5. And the trapezoid is 3 inches tall. So if I kind of drop that down, this is 3. And we want to know how long these two parallel sides are. So those two things I don't know, I'll call those x and y. And then we can use the fact that we know, first of all, that the perimeter is 42 inches. So the perimeter is just all the way around. That's going to be x plus y plus both of these 5s. So that's plus 10. And that's got to equal 42. Now, this is only one equation here relating x and y, and I need another one in order to be able to solve for two different variables. One thing that I do have is the height of this trapezoid, and notice that the way I've drawn this, okay, this comes down, it forms a right triangle. And with right triangles, we know that the Pythagorean theorem holds. So this length right here, that little length right there, we don't know what that is. I'm going to call it A. Okay, and we're going to find that. We've got a triangle here, right triangle, so a squared plus b squared equals c squared. So a squared plus 3 squared is equal to 5 squared. And that will allow us to at least solve for this a. Now, the reason that that's useful is because notice on the other side, I have the exact same thing. That length right there is also a. And then that leaves this middle section. Okay, well, that was really sloppy. That middle section actually is the same length right there. So it turns out that we actually have a relationship that x, I'll write this out, x plus these two side lengths, because this is x right here, both of those, so 2a, is equal to y. And I'm going to be able to solve for a right here. Let's go ahead and do that. We have a squared plus 3 squared is 9 equals 5 squared, which is 25. Subtract the 9, and we get a squared equals 16. So take the square root, and you get a equals 4. So up here now we have that x plus 2 times a, that's 2 times 4, which is 8, is equal to y. All right, so now I've got a nice pair of equations. I've got this right here and this right here, so relating x and y. Because y is equal to x plus 8, I can take that x plus 8 and I can put it in right here for y. Let's go ahead and do that. So we have x plus, and then y, which is x plus 8, and then plus 10 is equal to 42. Well, this is 2x, and then 8 plus 10 is 18, is equal to 42. We can subtract 18 from both sides. So we get 2x is equal to 42 minus 18, which is 24. Dividing both sides by 2, we get x is equal to 12. And if we take that and plug it in right here, we get 12 plus 8 is equal to y. So that tells us that y is equal to 20. So those are the lengths of those two parallel sides. And notice that we should put our units on those. That's inches. And so 12 inches and 20 inches are the lengths of the two parallel sides.